Hey guys, welcome to 12.3. We're still on geometric sequence and series, but today we're going to talk more about infinite sums. So I think the other day we did finite geometric series and we learned a formula to find the sum of a finite geometric series. But what about one that approaches infinity? What if it's an infinite geometric series? And the easiest way to look about these is to write it a different way. What if instead of 1 to infinity, we stop at n? So k goes from 1 to n of the same geometric pattern here. And then this would now be a finite geometric series because it stops at n. Okay, now in calculus we say the limit of this summation as n approaches infinity. So as n gets bigger and bigger and bigger, this finite series, if it approaches some number L, then we say that the series converges. Okay, so if this finite sum approaches a number L, then the series converges. If it doesn't approach some number L, then it is divergent. So two words, converge, diverge. Converge is if the finite sum approaches a number. Divergent is if it does not. And the easiest way to tell is very simple. If the absolute value of r is less than 1, then this infinite series will converge. And the way to find the sum is this formula right here. So this is the formula for the sum of an infinite series that converges. And this formula will be given. You just have to know when to use it. Okay, so number 1, determine if the series converges or diverges, and then if it converges, find its sum. So again, really easy. Just look at r. R is going to be the base of the exponent here. 2/3 is less than 1, so it will converge. Okay, if the absolute value r is less than 1, it will converge. Now, what is the sum? We're going to use our new formula here. A sub 1 over 1 minus r. So a sub 1 is obviously 2, and 1 minus r is 2/3. So this would be 2 over 1/3, because 1 minus 2/3 is 1/3. Multiply by the reciprocal, you would get 6. So this infinite series will approach 6, its sum. Okay, flip it over. Let's do some applications of this. So number 2, we have a pendulum on a clock swinging. It's got an arc of 18 inches. And then on each next swing, the length of the arc gets less, 0.98 of the previous. So A is saying, what is the length of the arc on the 10th swing? Okay, and this is a geometric sequence here because 0.98 is, we're going to be multiplying, right? And geometric is when you're multiplying. So yeah, so let's set up our geometric sequence formula, which is, pull it out here, a sub n equals a sub 1 times r to the n minus 1 power. Okay, that's our geometric. So a sub n equals a sub 1 times r to the n minus 1 power. And then we just plug in what we need. It says the 10th swing, so we're going to plug in 10 for n. So a sub 10 equals a sub 1, which would be 18. That's the starting arc. R would be 0.98, and n will be 10. So 10 minus 1, I'm just going to call 9. And then we can calculate that and see what we get. So 18 times 0.98 to the 9th power, you get about 15.007. So about, I'm just going to put about 15 inches. B, on which swing is the length of the arc first less than 12? So now on this one we have to find N. On what swing? And we should be able to know everything else. Okay, instead of doing less than 12, why don't we start by just doing equal to 12, and then we'll go from there. So A sub 1 we know is 18 again. R is still 0.98. N this time is missing. On what swing? All right, so you guys are going to solve this. We're going to start by dividing both sides by 18. So 12 divided by 18 is 2/3 equals 0.98 to the n minus 1 power. Now, how do you solve for n? We're going to have to use logs, right? We're going to have to log both sides. So log both sides. Remember, when you log, the exponent drops down to the front. So now we have log 2/3 equals n minus 1 times log of 0.98. And now you guys have to solve for n. So a couple ways. I would probably divide these and then just add the 1 over to get n. So I would probably do log of 2/3 divided by log of 0.98. And then I would just add 1 to isolate n. All right, so n is 21.07. But that means that somewhere after the 21st swing, you hit 12 inches. We want less than 12. So that means that we're going to have to round up to the next swing to actually get less than 12. So final answer would actually be on the 22nd swing. That's when we would fall below 12 inches. Not below, less than 12. Okay, C says, after 15 swings, what is the total distance? Okay, total distance is a sign that we want to use a geometric sum formula. So let's pull out our formula sheet. Which one of these is for a finite, because it says 15 swings, finite geometric sum? That's going to be this one right here. A sub 1 times 1 minus r to the n over 1 minus r. I don't remember when we did that. Probably yesterday. All right, so the sum is going to be a sub 1, which is 18, times 1 minus 0.98 to the 15th power over 1 minus 0.98. I'm just using that formula. And then just type it in. So 18 times 1 minus 0.98 to the 15th power all over 1 minus 0.98. And that would be about 235.3 inches. Cool. Okay, so that was a finite sum. Now D says when it stops, what was the total distance it has swung? So we don't know n on this one. Okay, this would be like an infinite series. We need to find the sum of the infinite series. So that's this new formula that was on the front of today's notes. The sum of an infinite geometric series is a1 over 1 minus r. Because the saying is n approaches infinity, what is the limit of the finite series? Okay, so a sub 1 is 18 over 1 minus r. And then that's it. So 18 over 1 minus 0.98, you get 900. So 900 inches. Awesome. Okay, another application. This one's about bouncing balls. A ball is dropped from a height of 30. Every time it hits the ground, it bounces up 0.8 of the previous height. Okay, so this is geometric, obviously, where the r is just 0.8 because you're multiplying by 0.8 every time. So how many times does the ball need to strike the ground before its bounce is less than 6? So let's use our same formula. A sub n equals a sub 1 times r to the n minus 1, because this is for geometric. How many times does the ball bounce? That means we're solving for n. And we want the height to be less than 6. So kind of like before, let's just use 6, and then we'll figure out the answer. So a sub 1, initial height is 30. R is 0.8, and we're trying to find n. All right, so same as before, we're going to use logs. I'm going to start by doing 6 divided by 30. And then I'm going to do log of that divided by log of 0.8. And then I'm just going to add 1. Okay, so I got, oh, you know what I forgot to do? Oh, sorry guys. This is in feet. This is in inches. So we need to do a conversion. So 6 inches is how many feet? It's half a foot. So this should be 0.5. All right, redo. So now it's going to be 0.5 divided by 30. And then it's log of that divided by log of 0.8. And then we're going to have to add the 1 over. Just like last time, I got about 19.3. Okay, so now in 19.3 bounces, we're at 0.5 inches. But we want it to be less than 0.5 inches. So we need to round down to the nearest times that it bounced. So that would be 19 times. All right, part B. What total distance does the ball travel before it stops bouncing? This will be another infinite sum, infinite geometric sum. And that, again, would be this formula. A sub 1 over 1 minus r, the sum of a geometric infinite series. Okay, so a sub 1 is 18. 1 minus r is 1 minus 0.8. All right, and if you calculate that, you will get your answer. 18 over 1 minus 0.8, and that is 90. Okay, so now this one's a little tricky. Oh my gosh, I just used 18 from this problem. It's 30. Oh my gosh, you guys. All right, change that 18 to a 30. 150. Okay. Sorry, I was thinking about the other problem. So 150, but now we have to be careful. Every time it bounces the same distance the other way. So this is only counting one direction. So we got to be careful. Okay. See how we have equal distances up and down, like 24 and 24, 19.2, 19.2. So because every bounce has an equal opposite direction bounce, we're going to have to multiply this by 2. But then there's one bounce that does not have a partner, and it's that initial drop. So we have to subtract that out. Okay, so because every bounce has a partner, we multiply by 2, but the initial drop never bounces back up to 30, so we subtract out that partner. And this gives you a final answer of 270 times. Or feet. Sorry, feet. Okay, so a little tricky on those. We can talk about it in class if you want. And then 4, we've done this with arithmetic. Now we're going to do it with geometric. So find x so that these are consecutive terms of a geometric sequence. Okay, if it's geometric, then if you divide a term by its previous, it's going to equal the same number as if you divide another term by its previous term. Okay, so we're going to set up that proportion. So I'm saying if we take x plus 2 over x, okay, a term and its previous term, that ratio is going to be equal to x over x minus 1 because they are also previous consecutive terms. And now we just have to solve. So if you cross multiply, you get x squared equals x squared, you're going to FOIL, right? Plus x minus 2. And then if you solve, these cancel, and then just add the 2 over, so x would be positive 2. All right, nice job, guys. This was, again, infinite geometric series, summation, and applications of it. Thanks for watching.